students, so finally we are at the last lecture of this exercise 6.2. This is the lecture number 20, and in this lecture we will solve two problems, the two remaining problems from the exercise 6.2. So let us start the first question. So according to the first question, there is a figure, and from this figure it is given that there are two lines AB and CD, AB and CD, and these two lines are parallel to each other. Understood? Then the angle APQ is equal to 50 degree. The angle APQ, this angle is equal to 50 degree, and the angle PRD, this angle is equal to 127 degree. Okay, these are the basic data that has been given in this figure. Now by use this data, you have to find the value of the two unknown terms x and y. Right? So here we have the value x and y. We need to find these two unknown variables value by using the following data. Okay? So as it is given that the line AB is parallel to the line CD. Okay? So let us first find the value of x. Okay? So we will first go for finding the value of x. Now as it is given that AB line is parallel to CD line, consider this PQ as a transversal line. This PQ is a transversal line. So PQ is transversal. Clear? Next, if AB and CD are two parallel lines and PQ is a transversal line which intersect AB and CD at two distinct points P and Q, then this angle and this angle are known as alternate interior angles. Forget about this line. Consider only these two lines and this transversal line. Then you can see that this line, so this angle and this angle are known as alternate interior angles. And according to the theorem number 6.2, the pair of alternate interior angles will be equal. Okay? So here we can write this angle is equal to this angle. Okay? This angle and this angle are equal. So angle APQ, this angle is equal to this angle PQR is equal to PQR. Okay? Now it is given that the angle APQ is 50 degree. So in this place you have to substitute 50 degree is equal to PQR. PQR is how much? X. So here we find that the value of x to be 50 degree. Okay, it is very simple. Now we will go for finding the value of y. How can you find? See, CD is a straight line, and on the straight line, this is a ray which stands on this straight line. Yes, so write it. This is the value of x. Now we will find the value for y. Okay, so CD is a straight line and on which this ray stands. PR stands. Okay, so this is the straight line on which this is a ray. Now two angles are formed, this angle and this angle, and these two adjacent angles are known as linear pair angles. Do you know the sum of two linear pair angles is equal to 180 degree? Okay, so we can write this angle PRD plus this angle PRQ is equal to 180 degree because they are linear pair. Okay? Now, here also you have to write the reason why they are equal, because they are alternate interior. I have forgotten to write it. Okay? Due to axiom, due to a theorem 6.2. Now, these two angles are ready to give 180 degree. Okay? Now, the value of PRD is 127 degree. plus PRQ is equal to 180 degree. Now we can find this value. So PRQ is equal to 180 degree minus 127 degree, which is equal to 53 degree. Hence we find the value of angle PRQ is equal to 53 degree. Okay, so this value is 53 degree, and we find the value of X to be 50 degree. Okay, this is 50 degree. So we will now go for the finding the value of Y. Okay, so for this, consider this triangle. This is a triangle. QPR is a triangle. So QPR is a triangle. Now in a triangle, the sum of the three angles is equal to 180 degree. So this angle, that means 50 degree plus this angle Y plus this angle 53 degree is equal to 180 degree. Because the sum of three angles of a triangle is equal to 180 degree. Okay. Next, 50 plus 53, 103 plus Y is equal to 180 degree. Okay. So Y is equal to 180 degree minus 103 degree. Okay. So it will be 77 degree. Okay. Hence we find the value of Y to be 77 degree. So this value is equal to 77 degree. Okay. So finally we find the value of X and Y. X is equal to 50 degree and Y is equal to 77 degree. Understood? Coming to the last question of this exercise, that is question number 6. Okay. So question number 6 is a science based question. So let us read this question carefully. Right. So according to the question, it is given that PQ and RS are to mirror. PQ and RS are to mirror. What are the mirror? Mirror are something on which whenever a light focus on it, then it will be reflected back. That is known as mirror. Okay. And both the mirror are placed parallel to each other. So PQ mirror is parallel to RS mirror. Understood? Now an incident ray AB strikes the mirror PQ at B. It means someone focuses a torchlight, okay, from this side to the mirror PQ, so that the light ray goes and strike at B. Okay, and this light ray is known as incident light or incident ray. You have already studied in the science subject, right? So this ray is the incident ray. Now whenever this ray strikes at B, then from that point it will be reflected back. So it reflected back in this direction BC, which is shown by an arrow mark. Okay, the reflected ray moves along the path BC. So this is the reflected ray. This is the incident ray, right? So you can say this is the reflected ray. Okay, and strikes the mirror at C. Then what happens? This reflected ray BC again strikes on the mirror RS at the point C. So what will happen? It will again reflect back. So it will again reflect back in the direction CD and again reflects back along CD. Okay, so this is the basic question. Okay, so these are the two mirrors. This is the incident ray which strikes at B, again reflected back, and strikes at C and again reflected back. And it is given that these two mirrors are parallel to each other. Okay, now you have to prove that AB is parallel to CD. AB means this line. Okay, so this line AB is parallel to this line CD. We have to prove it. We can extend it, no problem. We can extend it like this. Okay, so we have to prove AB line is parallel to CD. Okay, how can I prove it? So in order to prove this, we have to construct a normal. What is normal? Normal is a line which is perpendicular to the mirror. Okay, suppose this is the mirror. Okay, this is the reflected side. Whenever a ray focuses on it, it is known as incident ray. Then it will be reflected back in this direction. Now normal is a line which is perpendicular to the mirror. If this is the mirror, then this is the normal, which is perpendicular to the mirror. And you know the law of reflection, that the angle of incidence is equal to the angle of reflection. This is the first law of reflection. Angle of incidence is equal to angle of reflection. This is the first law of reflection. It means the angle made by the incident ray on the normal line, okay, is equal to the angle made by the reflected ray with the normal line. Okay, this is the angle of reflection. This is the angle of reflection. Okay, angle of reflection, and this angle is the angle of incidence. So according to the law of reflection, the angle made by the incident ray with the normal line, suppose this is M, BM is the normal line. So the angle made in between the incident ray and the normal line is equal to the angle made by the normal line with the reflected ray. This is the law of reflection. Okay, so we will first construct a normal line BM. So construct normal line BM, okay, which is perpendicular on the mirror PQ. Understood? Similarly, here also it incident and it reflects. You have to again draw another normal line CN, which is perpendicular on RS, and normal line CN perpendicular on RS. Okay, so these are the two normal lines that has been perpendicular on PQ and RS respectively. Okay, and I have told you that the angle of incidence is equal to angle of reflection. It means this angle is equal to this angle. Okay, so the angle ABM is equal to the angle MBC. Why? Because law of angle of reflection. Okay, since these two angles are equal, then can we say BM is the angle bisector? Yes, BM is the angle bisector. So that the total angle, this is the total angle, has been divided into two equal halves, and each halves are equal. So we can say BM is the angle bisector. Okay, so we can say BM is the angle bisector. Okay, and if it is the angle bisector, then we can write that this angle, this portion is the half of the total angle, or this portion is the half of the total angle. Okay, so write it. So this angle means the angle CBM, this angle implies CBM angle is the half of the total angle. Total angle is ABC. And I have write the reason that BM is the angle bisector. Understood? Similarly, see, this angle must be equal to this angle. Why? Because this is the angle of incidence. Because on this mirror, this light focuses and strikes at C and again reflects back. So this is the angle of incidence. This is the reflected ray. So this angle must be equal to this angle. Okay, so we can write that CN is the angle bisector. Okay, so first write this angle is equal to this angle. So BCN is equal to this angle means DCN. Why? Due to the law of reflection. Okay, since these two angles are equal, so CN is the angle bisector. So CN is the angle bisector. Okay, so we can write this portion is the half of the total angle, or this portion is the half of the total angle. Okay, so write this portion, that means the angle BCN. So we can write BCN is the half of the total angle. Total angle is BCD. Okay, so the total angle is BCD. Okay, so this is the equation number 1, and this is the equation number 2. Okay, now look at this figure. BM and CN are two normal lines. Normal lines means they are perpendicular to the line PQ, and this line perpendicular to the line RS. Okay, and PQ and RS are two parallel lines. Now, one thing you have to keep in mind, that if there are two parallel lines, okay, and in between these two parallel lines we draw two perpendicular lines like this. These are two parallel lines, and in between them these are two perpendicular lines. This is perpendicular to this line, and this is perpendicular to this line. You can extend their lines. Okay, then these two lines must be parallel. Okay, this concept has to be remembered. If in between two parallel lines you draw two perpendicular lines, okay, then it will be 90 degree. Then it will be 90 degree. Then it will be 90 degree, and it will be 90 degree. So that they will form a rectangle. And in a rectangle, you know, the opposite sides are parallel. Hence, if you draw any in between any two parallel lines, two perpendicular lines, then this perpendicular lines must be parallel. Okay, so like this, in this figure also, the line BM and the line CN must be parallel. Okay, here BM is parallel to CN. Okay, and forget about everything, just consider BM and CN, and this is the transversal line. CB is a transversal line. Okay, so and CB is transversal. Okay, so BM, CN are parallel lines, and this is a transversal line. Then what is the relationship between this angle and this angle? Tell me. This angle and this angle are alternate interior angles. This angle means MBC and NCB are alternate interior angle, and according to the theorem 6.2, the pair of alternate interior angle will be equal. So you can write this angle, that means MBC, okay, or you can write CBM. So CBM is equal to this angle, okay, that is BCN. Okay, what is the reason? The reason is that they are alternate interior, or due to theorem 6.2. So we find CBM angle is equal to BCN angle. So this angle is equal to this angle. Okay, now look at the equation 1. In equation 1, we find that the angle of CBM is equal to half of the total angle. CBM is equal to half of the total angle ABC. So in the place of CBM, we can write or we can substitute half ABC. Half of angle ABC. Similarly, look at the equation 2. In equation 2, we have BCN, and BCN angle is equal to half of the total angle BCD. BCN means BCN. This angle is the half of the total angle because this is the angle bisector. So this angle is the half of the total angle. Total angle is BCD. So in the place of BCN, we can substitute half of BCD. Okay, now it is understood. Now, what we will do? We can write half of ABC edge, ABC by 2. We can write half of BCD edge, BCD angle by 2. No problem. Now this 2 has been taken to the right hand side. So it will be angle of ABC is equal to 2 when goes to the right hand side, it will be multiplied with BCD by 2. So 2 cancelled out. So finally what we get? So finally we get that the angle ABC is equal to the angle BCD. This is the final result. So finally what we get? So finally we get the angle ABC. ABC. That means which angle? Erase everything so that it will be easy to understand. So the angle ABC, ABC, this angle is equal to the angle BCD. BCD. This is D. Okay? So BCD. This angle. So erase this thing. This angle. Okay? So finally we get this angle is equal to this angle. Okay? Now tell me. We have to prove AB and CD will be parallel. Consider the line AB and another line CD. This is AB and this is CD. And this is a transversal line. Okay. Now, you find that this angle and this angle are equal. Then tell me, what is the relationship between this angle and this angle? If AB and CD are two lines and this BC are the transversal line. And what is the relationship between this angle and this angle? These two angles are which type of angle? They are alternate interior angles. Okay, so let us write it. So AB and CD are two lines and BC is a transversal line. Okay, so if it is a transversal line, then these two lines are, these two angles are alternate interior angles. But what you find here? You find that this angle is equal to this angle. It means the alternate interior angles are equal. Okay, according to the theorem 6.3, if in between two lines a transversal line intersect such that the pair of alternate interior angles will be same, then these two lines are parallel. This is the theorem number 6.3. Okay, but we get this angle is equal to this angle, which are alternate interior angles. Okay, so these two are alternate interior angles and they are equal. Now according to the theorem 6.3, if in between two lines and transversal line is intersected, then the pair of alternate interior angles if equal, then we can say this line is parallel to this line. Okay, so hence we can write AB is parallel to CD. Why? Due to theorem 6.3. Hence it is proved. Okay. Again I am telling you how it is proved. First you have to draw two normals. Okay. So that this angle and this angle will be equal, because angle of incidence is equal to angle of reflection. This equal. So this is the angle bisector. Now you can write that this angle is the half of the total angle, like this. this angle is the half of the total angle. Similarly, here also this angle and this angle are equal. So we can write this angle is the half of the total angle. Understood? Now, this line and this line are parallel, and these two angles are alternate interior angles. Do you know, according to the theorem 6.2, in between two parallel lines, if there is a transversal line, then the pair of alternate interior angle will be equal. So we find that this angle is equal to this angle. Okay, now in place of this angle, we substitute this angle, and in place of this angle, we substitute this angle here. Now this 2 can be cancelled out, and finally we find the angle ABC. That means this angle is equal to the angle BCD. BCD. That means this angle. Now, if you consider this line AB and this line CD, and this is the transversal line, then what is the relationship between this angle and this angle? They are alternate interior. And according to the theorem 6.3, we know that if in between any two lines there is a transversal line, and if the alternate interior angles are equal, then they are parallel. The two lines are parallel. Here we find that this angle is equal to this angle. So we can write that the line AB is parallel to the line CD, and it is proved. Okay.